Good morning, dear students. My name is Ferhan Mazher, and today we are studying O levels mathematics. The code of the subject is DMaths 4024. This is Cambridge O levels mathematics, and we are working on the syllabus. And today we are working on an exercise 13A from the book D3. The name of the book is New Syllabus Mathematics 7th edition. It's 13th chapter, which is the last chapter of that exercise. And this exercise is about circle properties. So we are studying the first exercise, and this is about the perpendicular bisector of a chord of a circle. So this is the second video on this exercise. In my first video, which I have already uploaded in my YouTube channel, we have solved from the question number 1 to question number 5. In this video, we will try to solve from question number 6 to question number 11. All the questions, they are related with the circle properties and especially the perpendicular bisector of a chord. The property is that the perpendicular bisector of the chord is always perpendicular to the chord and it bisects the chord. So this is the main idea around which this exercise is. So let's start this exercise and let's go to the exercise. Okay, so 13A exercise from the D3 book, and this is New Syllabus Mathematics 7th edition. We are working on the question number 6. So here we go. The question number 6 is coming up on your screen. So question number 6 is showing up on your screen. He says the figure shows the cross section of a circular water pipe. The shaded region shows the water flowing through the pipe. Given that PQ is 9.6 centimeter, this chord is 9.6 centimeter, and that the surface of the water is 3 centimeter below the center O of the circle. So the distance of this chord from the center of this circular pipe is how much? 3 centimeters. So this dimension is 3. The length of the chord is 9.6. Because this is perpendicular, we suppose it's perpendicular. So this will be divided into 2 equal parts. So this will be the perpendicular bisector of the chord. So it will be 4.8 and this portion will be also 4.8. The question is find the cross-sectional area of the water pipe. Actually, we want to find out the cross-sectional area of this shaded region, which is showing the water. And this is a segment. So I need to know what is the radius of this big pipe, and then I will try to find out, first of all, I will find out this radius, then I will find out the area of this sector. From the area of this sector, I will subtract the area of this triangle. The remaining will be this shaded area, which is the main question. For this purpose, I need to find out the radius and I need to find out the angle here. So once I know that, or you can, I need that angle. So I will use some sine cos tan and then I will be able to do this. So let me show you. So on your screen, the question number 6 is showing up. Okay. So here is that circle. That circle is not that clear because this has been drawn with the help of a lead pencil. Okay, so this was the chord that was 9.6 centimeter long. So this is from the center, the perpendicular bisector of the chord, with this dimension is 3. So this is 4.8. So apply Pythagoras, you will be able to find out the radius. So here you can see r square is equals to 3 square plus 4.8 square. So r square will be equals to 9 plus 23.04. R square will be equals to 32.04. Take square root on both the sides. So R will be equals to square root of the 32.04. So R will be 5.66 centimeters. So the radius of this big pipe is 5.66 centimeters. So that then the cross sectional of this whole pipe, that is not required here. I just calculated it. Pi r square. Pi into 5.66 square is equal to 100.66 centimeters square. This is not required here. I want to know what is this angle. How much is this angle? If I want to know this, suppose this angle is theta. So I will I know the base, I know the perpendicular, so I can find this angle. Use tan theta is equal to 4.8 divided by 3. So theta will be tan inverse bracket 4.8 divided by 3 bracket close, and that theta will be 58 degree. So this angle is 58. This angle will be also 58. So the angle between these two radius will be 2 times 58, and that will be 116. So I will find the area of this sector. You remember the area of the sector is theta by 360 pi r square. So 116 is the angle here subtended by this sector at the center, divided by 360 pi r square. R is 5.7 square. So the area of this sector, will be 32.9. Then I will find the area of this triangle. I know this side, I know this side. I know the angle is 116 between these two sides. So you can find the area of this triangle OPQ. The formula is 1 by 2 AB sine theta. So it will be 1 by 2 into 5.7 into 5.7 into sine of 116. And the area 2 will be 14.6. From the area of the sector minus the area of the triangles, you will have the area of this segment. The area of this segment. The area of the segment is equal to the area of the sector minus area of the triangle. And that is the area, cross-sectional area of the water. So it will be 32.9 minus 14.6, and that will be 18.3 centimeter square. So this is how, my dear students, we will solve this question. And here you can see the whole question. Just ignore this calculation. This was not required. I just did it. And this is, and then this is the thing. I hope you understand this question, how we have found the area of this cross section of the water. So this was how you have solved the question number 6. Now we are going to the next question. That's question number 7. He says the perpendicular bisector of a chord XY cuts XY at the N and the circle at the P. Given that the XY is 16 centimeter, the length of the chord is 16 centimeter, and the NP is 2 centimeter. Calculate the radius of the circle. So that is the question. So let me show you how I have done this. Okay. So on your screen, the question 7, this is the diagram. This is not to the scale. So we have drawn a circle, and this is the chord XY, and its total length is 16. So the perpendicular bisector coming from the center, it cuts the chord at the point N and the circle at P. So this NP distance is 2, and suppose that the radius is R. So from O to P, it will be R, N to P is 2, so O to N will be R minus 2. This portion is 8, this portion is R minus 2, this portion is R, radius, which we don't know. So I can easily find out this. So apply Pythagoras here. So hypotenuse is R square will be equals to R minus 2 whole square plus 8 square. So when you apply this, you will get R square. So here, this will be R square. This will be open with the identity. A minus B whole square is equals to A square minus 2AB plus B square. So it will be R square minus 4R plus 4, and this will be plus 64. So R square and R square will be cancelled. So you will have plus 4R equals to, this will be 68. 4R equals to 68 divided by 4, and R will be equals to 17 centimeter. So the radius of this whole, this circle will be 17 centimeter, and I hope you have understood the tricks which are involved here. Okay, so let's go to the next question, and the next question will be the question number 8, and here we go. So the question number 8 is showing up on your screen. He says the figure shows 2 concentric circles with the center O. The points A and E lie on the circumference of the larger circle, while the point B and D lie on the circumference of the smaller circle. Given that A, B, C, D, E is a straight line, and the OB, which is the radius of the smaller circle, is 9 centimeter, and AB is 6, this portion is 6, and the BC is 7, this portion is 7, and the AC AC is equal to CE. So this AC and the CE, they are equal. So this AC is basically 13. So the CE will be also 13. So their question is find the length of the OC and the length of the OE. So we want to find out the OC and then we want to find out OE. So very simple and straightforward question. Let me show you how this is done. Okay, so this is showing up on your screen. So these are two circles. This is the smaller circle. This one is the big circle. So here, this is OC is the first question. This portion is 7. This is 9. This is a right angle. So apply the Pythagoras here. So you will have, you can see that here we will have x square plus 7 square will be equals to 9 square. So x square will be equals to 81 minus 49. So x square will be equals to 32. Take square root on both the side. So the x will be 5.5 centimeter. So it means that OC length is 5.7 centimeter. Then, you know, this portion, in the question, he told us that the AC and the CE, they are equal. AC is 13. So CE is also 13. I know OC, I know CE, and it's a right angle triangle. So I can apply the Pythagoras and I can find the value of the OE. So you can see here we are applying the Pythagoras, and OE square will be equals to 5.7 square, which is OC, plus CE value is 13 square. Hypotenuse square is equals to perpendicular square plus base square. So OE will be equals to, just do it in the calculator. You will have OE square will be equals to 201.49. Take the square root of the 201.49 and you will get 14.2 centimeter. So this is how you will do the question number 8 of this exercise. The whole question 8 is showing up on your screen. You can pause the video and you can take time and you can have a look at this question. Okay, so my dear students, we are moving to the next question. The next question is question number 9 showing up on your screen. He says, the lengths of two parallel chords of a circle of radius 5 centimeter and 6 centimeter. The lengths of two parallel chords of a circle of radius 5 centimeter are 6 centimeter and 8 centimeter, respectively. So they are basically talking about two chords. One chord is of 6 centimeter length and the other chord is 8 centimeter length. The radius of that circle in which those two chords are is 5 centimeter, and both the chords are parallel to each other. But find the distance between the chords. Okay, we have to find out the distance between the chords. Both the chords are parallel to each other. Here, there is one problem. He has not told us that the parallel chords are on the same side of the center or they are opposite on the opposite sides of the center. So we will make two cases. In one case, we will put both the chords on the opposite side of the center. And in the second case, I will put both the chords on the same side of the circle. Let me show you what do I exactly mean. Okay, so we are talking about the question number 9. It's coming up on your screen. And this is the case number 1. Here we have two chords, AB, which is 6 centimeters, CD, which is 8 centimeter. The distance of they are parallel to each other, and the distance of the AB from the center is A, suppose A, and the distance of the CD from the center is B. The distance between the chords will be A plus B. And we know the radius of the circle, that is 5 centimeters, because this is the perpendicular bisector. So here the angle will be 90. This portion will be 3 and this portion will be 3. The radius is 5. So here I can apply Pythagoras and I can find out the value of the A. So it will be A square plus 3 square equals to 5 square, radius square. So A square is equals to A square plus 9 is equals to 25. A square is equals to 25 minus 9. A square is equals to 16. A will be equals to the square root of the 16 and A will be 4. So the distance of the AB chord from the center is 4. Here, this is the perpendicular bisector of the chord. The distance of the chord from the center, I'm supposing it's B. Here, this chord will be bisected. So this angle will be 90. This portion will be, because the total length is 8. So this portion will be 4. The radius is 5. So apply the Pythagoras. you will have b square plus 4 square equals to 5 square, b square equals to 25 minus 16. So b square will be equals to 9. So b will be equals to square root 9 and b will be equals to 3. Now I know the value of the b, it is 3, the value of the a is 4. So the distance between both the chords in this situation, in this case number 1, it will be a plus b, so it will be 4 plus 3 and 7 centimeter. It means the distance between the AB chord and the CD chord is 7 centimeter. Here in this case, we have supposed that both the chords are on the opposite sides to the center. Okay, so in the case number 2, we will suppose that both the chords are on the same side of the center. So for example, AB, which is 6 centimeter, CD, which is 8 centimeter, they are on the same side of the center. The distance of the AB from the center is suppose A, the distance of the CD from the center is B, and we know the radius is 5. So what I will do, here you can see this right angle triangle, the radius is 5, this portion is 3. So I will find the A value, apply the Pythagoras as you have done in the previous case, the A value will be 4. In the same way, this portion is 4, this portion is 4, this is the radius, which is 5, this is the distance of the CD chord from the center, and that is B. So apply Pythagoras here, 4, 5, and this B. So you will get the B value as 3. In this situation, the distance between the chords is A minus B. The A value is 4 and the B value is 3. So A minus B will be 1 centimeter. So here, when the chords are on the same side, the distance between them will be 1 centimeter. So hopefully you understand this whole story and how we have done this question. Okay, so we are going to the next question. The next question is, he says, 2 parallel chords PQ and MN are 3 centimeter apart on the same side of a circle, where the PQ is 7 centimeter and the MN is 14 centimeter. Calculate the radius of the circle. So here we have 2 parallel chords. One chord is PQ, whose length is 7 centimeter. Other chord is MN, its length is 14 centimeter, and the distance between them is 3 centimeter. They want us to find out the radius of this circle. So let me show you how this is done. This is question number 10. So here we have drawn a diagram, and this diagram is not up to the scale, it's just for understanding. So we have drawn a circle. Here we have a chord, its name is PQ, total length is 5 centimeter. The perpendicular bisector from the center will bisect it. So this portion will be 3.5, this portion will be 3.5. This is the other chord MN, whose length is 14. So this perpendicular bisector, it will divide into 2 portions. One portion will be 7, the other portion will be also 7. This angle is 90, this angle is 90. The distance between them is 3 centimeters. Suppose that the distance of the first chord from this MN chord from the center is X. So the distance of the PQ from the center will be X plus 3. So I don't know the radius, so I will try to find out the radius. So you see, first of all, I take this triangle, this one, NO and this, okay? So this is X, this is 7, this is R, so apply the Pythagoras. So you will have X square equals to X square plus 7 square equals to R square. So X square will be equals to R square minus 49. So here we have 2 variables. We don't know what is the value of the X. We don't know what is the value of the radius. The main question is, what is the value of the radius? So this is one equation. We have 2 variables and we will make 2 equations and then we will solve them simultaneously. Okay, now I will take this triangle, this right angle triangle. The radius is R, this perpendicular is 3.5 and this base is X plus 3. So X plus 3 whole square plus 3.5 square is equals to R square. So here I open it with the identity, A plus B whole square is equals to A square plus 2AB plus B square. So it will be X square plus 6X plus 9 plus 3.5 square is 12.25 equals to R square. So it will be X square plus 6X plus 21.25 equals to R square. So in the place of R square, I will put this value. R square is equals to X square plus 49. In the place of R square, I substituted that value which came from this equation. So now you can see the whole equation is in the single variable. X and X will be gone. 6X will be equals to 49 minus 21.25. And 6X will be equals to 27.75. So X will be equals to 27.75 divided by 6, and that will be equals to 4.625. So now I got the value of the X. The main question was, what is the radius? The radius R square is equals to X square plus 49. I know the value of that, just substitute that X value here. So R square is equal to 4.625 square plus 49. So the answer will be 70.39. Take the square root on both the sides. So R will be equals to 8.39. A little tricky question because it involved two variables and two equations. So I hope that you have understood this question. The whole question is showing up on your screen. You can pause the video and you can take your time and try to understand and absorb that question. Okay, so let's move to the next question. The next question coming up on your screen is the last question of this exercise. The radius of a circle is 17 centimeter. A chord XY lies 9 centimeter from the center and divides the circle into two segments. Find the perimeter of the minor segment. So this is the question. So let me show you. We have to find out the perimeter of the minor segment. So here we have drawn a circle. This is the center. This is that chord. And we know that the chord is 9 centimeter from the circle. So this perpendicular bisector is 9 centimeter from the O. The radius is 17. So I can find the half portion of the chord, which is, I have named it as A. So A square plus 9 square equals to 17 square. So A square equals to 289 minus 81. So A square is equals to 208. So take the square root on both the sides. So A is equal to the square root 208 equals to A will be equal to 14.42. So once I know this, then I can find the length of the chord. The length of the chord will be xy equals to 2 times A, and that will be xy equals to 2 times multiply. This A is 14.42, so the chord will be 2 times this, so that will be 28.8 centimeter. Then I will try to find out this angle here. So I will apply the cos theta. So I know the base and the hypotenuse. So cos theta will be 9 by 7. So theta will be cos inverse bracket 9 by 17. So I said 7. It's 9 by 17 bracket close. So theta will be equals to 58.03. So this XOY total angle will be 2 times 58.03. So it will be 116. So I will try to find out the length of this arc XY. You remember the formula of the arc is theta by 360 2 pi r. So theta here at the center by this arc is 116 divided by 360 into 2 pi, and the radius is 17. So the length of this arc XY, which is not very clear here, is 34.42. And the perimeter of this shaded region will be this chord XY and this arc. So the perimeter will be the length of the chord is 28.8 plus this arc, which is 34.42, and the total perimeter will be 63.42. I hope that you have understood this question. The question number 11. The question number 11 of the exercise 13A from the book D3, New Syllabus Mathematics, 7th edition, which was the last question of this exercise, is showing up on your screen. You can pause the video and you can take your time and you can absorb that question. I hope that you have understood this question. So, my dear students, this by doing this question, we have reached the end of this exercise. So today, this was the second video on this exercise 13A from the book D3. And we have completed from question number 6 to question number 11 in this video. Question number 1 to question number 5 I have done in another video, which is already uploaded in my YouTube channel. I'm trying to do this chapter, and I hope that this will help a lot of students around the world. And if you find this video interesting and useful and helpful, Please share the link of this video onto your Facebook accounts, onto your Twitter accounts, onto the Facebook groups which you have joined, where we have the students, so that this exercise can reach a lot of students. And this is also a great appreciation for me for my work. It's a great blessing for me that I am able to do this. I'm thankful to God. So keep praying for me. So thank you very much, everybody. Have a good day. God bless you.